Hi everyone, I am Vamshi Karanam. I am working on the coal-fire-induced land subsidence in Jharia Coalfields, India. Coalfields are the lifeline for electricity generation in India and across the world. Jharia Coalfields or JCF are located in the Dhanbad district of Jharkhand state in India. It houses 89 collieries and these coalfields carry immense importance because they house the premium coking coal and are among the most densely populated coalfields globally. JCF is severely affected by coal fires since last century. Coal fires burn the underground coal, creating voids. Then the supportless overburden starts to settle, resulting in land subsidence. This leads to creation of cracks and fissures over the surface that act as inlets for oxygen, thereby intensifying the coal fires. To address this issue, we have conducted a PS-sensor analysis of 60 Sentinel-1 SLC images captured between 2017 and 2019 using the STAMPS method to deduce the subsidence velocities. Later, we have performed tropospheric correction by estimating the error using Gecko's maps with the help of the train software package. The results are decomposed to obtain vertical subsidence information. Simultaneously, the average thermal anomaly maps are computed using several Landsat 8 TIR band images to detect the coal fires. Then, the vertical subsidence maps and the coal fire maps are overlaid to understand the correlation between the two. The study period is divided into two phases to analyze the progress of these hazards. Phase 1 is from November 2017 to April 2018, while Phase 2 is between November 2018 and April 2019. The subsidence results for the first phase show several localized subsidence zones subsiding at a rate of 10 to 20 centimeters per year. Most of the subsidence zones are in the northern and eastern parts of the coalfields, where mining is active. We identified 6 such zones, and these zones are overlaid over the subsidence maps of the next phase to see that they fit perfectly. In addition, we noticed 2 new subsidence zones and named them A and B. The same is overlaid on the coal fire maps and they coincide with the anomalous regions here. To better understand the relationship between these two hazards, we have zoomed into few zones. The first zone primarily lies over Keshalpur colliery and is extended to the neighboring collieries. The intensity of the subsidence here is up to 15 centimeters per year. We can see the northward expansion of subsidence and coal fires. The subsidence has also intensified, as can be confirmed from the time series graphs. A new subsidence center broke out in the second phase in the West Mudidih colliery on the right of the first one. The second zone is along the corners of the 3 collieries as shown here. The area is also affected by coal fires. A high intense coal fire phenomena in the Katras colliery on the left can be considered a warning for any future subsidence that may arise. The next zone carries immense importance as it is very close to settlements and is affected by both hazards over an extensive area. Nearly the whole of Kusunda colliery is affected by both the hazards. The increase in velocity and the coverage of the subsidence demands attention. Zone A is one such location where the coal fires are present throughout the study period and the area started subsiding only in the second phase. Though the affected area is small and away from settlements, this can be an excellent example in understanding the relationship between the subsidence and coal fires and the impact of one on the other. Then the zone B is also similar to the previous one in terms of the velocities of the above discussed hazard zones for both phases. One alarming thing to notice is the acceleration of the subsidence over the phases in all the cases. On an average, JCF is subsiding at a tremendous rate of 15 centimeters per year. Among the zones presented here, the subsidence at Zone A and Zone B is accelerating significantly. The next one is a graph comparing the subsidence and the coal fires affected area in each zone. For most of the zones, the area affected by both the hazards is the same, except for Zone 1. The presence of other triggering factors such as undocumented mining or the aging of pillars might be a reason for the broader coverage of land subsidence. In total, an area of 20 square kilometers is affected by the hazards. In conclusion, the efficiency of multi-sensor remote sensing data to estimate and monitor coal fire-induced land subsidence in Jharia coalfields is presented. The findings exhibit a positive correlation between the subsidence velocity and temperature anomaly in the study area. A majority of the hazard-prone areas are present in the northern and eastern parts of the coalfields, where mining is actively taking place and population density is also high, and thus requires immediate attention. The research strengthens the hypothesis that the coal fires are a major triggering factor for subsidence, and the subsidence can further aggravate the coal fires by pumping in more oxygen. Thank you.